Morning.
Come on, guys, you can do better.
Good morning.
That's the way to go. Still early? Is it still early? Too early? It's already Friday, so we can understand how that feels. So, welcome to all the 8th graders coming on to the 9th grade. Are you all excited? Woohoo! No? No? Come on, you need some excitement. You got to finish the week with a bang. Right? Okay, so we will get right into it. My name is Miss Martha. I'm with EduSeats. And before I introduce the trainer slash consultant and who's going to be with you the whole day today, we want to welcome all of you in here physically and also our online participants from all the different centers. We welcome you. Good morning. We hope that you will go back taking away good stuff, good tips. All right. And it's going to be an exciting day. So even if you're not excited, just pretend to be excited. Okay. So this workshop is going to be trained and handled by Dr. Lai. Right? He is one of our consultants. He's from Singapore. He has written maths books. He has done a lot of consultations, but I'm not going to talk so much more about him. He will do it himself. So let the training begin.
Very good. All right, good morning. Can you all hear me at the back? Loud and clear. Good. Okay. Well, welcome to the workshop here. Okay, this workshop here, because you are the reason. So it's all for you here. All right, now you are not going to see this workshop as what you will see in your normal classroom. Okay, and over here, you have lots of hands-on activities and all the things there. It's a very much of an activity base. Okay, I understand that there will be some from other centers, and who are the students from other centers? A few of you? No? One, okay. Anyway, try to make friends, with your fellow students here. So, I think we know each other. Now, I think that the morning just started. It's a bit cold. I think all of you just now, I heard the good morning is still not very forceful, not very forthcoming then. Okay, why don't we begin? Now, let's begin. I have my program here planned out. Okay, I call this to be Math Explorers.
We use pi to calculate the area of a circle. The number pi essentially tells us how many times the diameter appears in the circumference. People create music out of the number pi by assigning each digit to a note on a musical scale. The notes are played according to the sequence of digits in pi. Let's listen to this piece of music of pi.
How do you like the pie music? Anybody who study music here? You play piano? Good. By the way, there are many people who compose different music using pi. You can try one by yourself, your own pi music. Okay, serious. You know pi, the digit, right? 3.14. By the way, it's not only 3.142. It's endless. If you take a calculator, punch it in there, you have a long list of digits, right? Yeah, so therefore, you can take that and you can form a musical scale and you can play it. Okay, this one here, what scale do they use? Do you observe it? You don't recognize it? It's a C scale, by the way. Okay, all right, now, so much for this one here. I think the morning is still quite cold. You want to play a game? The game is better, huh? Better than study, isn't it? Okay, let's play a game now. Okay, let's play a game. Okay, now, let me give you some paper first. Since it's a game, you want some paper. Can you ask me to pass the back? Okay, now pick which one. Okay, this one can be 2 persons share one sheet. It's okay. Two persons share one sheet. Just pass around. Come on, pass around. Whatever they did, 2 persons can share one sheet. Yeah. Huh?
This one is the worksheet, is it?
Worksheet, yeah. It's for the game. I'll tell you how to play this game. Now you can take 2 persons, you pair up 2 persons, okay? Play against each other. You can play with your neighbor. And you can use a different color pen. If you, let's say, you can use a black and you can use a red or blue, anything. Okay? So use different color. Okay, good. Good. Thank you very much. You put it here. Never mind. Good. Only to take out. No, I want to take out the cover. It's only the cover.
Only cover.
Only the cover. Yes, that's all. Yeah. Later. There's another thing. No, nothing to do with this bicycle now. Later. Don't worry. Okay, all got a piece of paper now. Listen closely how to play this game, okay? Now. Okay, these 2 persons have 1 game sheet. Now, I have altogether, I believe you have it. Can you get a piece? An extra? No extra. Never mind. In your case, it's a 5 by 5 square. Am I right? 5 by 5 dots. You can see that. But mine's only 4. It's okay. Because I have no space to put all the 5 by 5. So 5 by 5, if you look at it, how many squares can you form? The small little one.
9.
Are you sure 9? 25. Is it 25? Yes, 25. 25 small little squares. Am I right? You have forgotten your multiplication? 5 times 5 is 25. Okay, now the way you play this game is each person will take turn to do, okay? What you do is that you start on the grid here, one person take turn to join 2 adjacent dots. I can join, for example, I can join like this, anywhere, by the way, I can join like this, okay, but not diagonal, only straight. Either you draw horizontally, 2 neighboring points, you join together, or 2 neighboring points, you join in this way. Clear enough? Now, okay, I show you how this game is played, okay. Now, let's say first person draw a red line. Okay, now, A draw a red line, then B will draw another line. Anywhere, by the way. Don't have to be exactly here. He can draw anywhere. But I'm just show you that how that can be done. Okay. So now come to A's turn. So A will draw a line anywhere again. Then B will draw another line. Now back to A, back to B. Now see what happened. A can capture a square. Right? So he'll put a square there. You see that? So A captured the first square. And he will put his initial there, A. This is my square. You see that? That's how it's being done. Now come to B. Now, once you complete a square, You have another chance to draw another line. So now A says, since I complete a square, I can draw another line. So he draw another one. Second square. A put his initial there. Follow me? No, that's it. Okay, now he can draw another, because he complete a square, right? He will draw another, he will draw another red line. Now he draw here this time round. Then come to B. So B may draw here. Did you follow me? So you can draw anywhere. Whoever that complete the square at the end of the day, put your initial there. Clear? Who's the winner? Now at the end you finish you draw all the lines, right? So there'll be no line left, and you count number of squares. The one who has the most squares is the winner. Yes.
There's a tie.
25, can it be a tie?
There's 16.
You're 16?
No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
16, yours is 16, isn't it?
Yeah.
Okay, 16 square. Okay, will it be a tie? He said, possible. See if you can get a tie. If you get a tie, that means what? Both are equally strong. Am I right? You have a tie there, okay? So far, I'm yet to see there's a tie. There's always a winner and loser. Never mind, you try okay now. So you know how to do it, okay? Each person draw a line for us anywhere. Up to you. Okay? Now, the idea is this. You try to what? Stop your opponent to complete a square. Am I right? Yes, that's the idea there. Now, go ahead. See how you do it. Okay, you are no player. Anybody? There's one. How come you have none? Hey, I need one more player here. Anybody? Any volunteer? At the front. You can't play with the girl. She has no player. Okay, someone will partner you here. Come on. Someone will partner you here. Just coming. The teacher coming. Okay, they play the game with her. Okay. Now he can do it. Okay. No, he can draw another line.
Oh, I didn't know
Like, okay. Okay. One more line. Now you have to capture it now. You can. Now you see how to do, okay? You follow me. Okay, shall we stop for a while? Okay, now you can play it on, can you carry on by yourself? We'll move on to another item now. Okay, now let's go to the next activity. I just choose the meal. How to choose the meal? Okay, now I give you the meal here, by the way. Well, recess time, you'll go for your meal, am I right? So therefore here, just like in this picture here, you will go to canteen, the school canteen here, and then you choose the meal, what you want to eat. So I'm going to let you choose the meal here. Now, the handouts here, just a minute. Each person take one set. And okay, you can start cutting out the picture. Just a picture only, cut out the picture. Take one set, pass around. Take one set, pass around. If not enough, don't worry. Raise your hand. Pass around, pass to the back, wherever they are. Pass around. You have to pass it out. I will get one set for myself. Give me one. Good. One more. I need one more, so you get to take it. One more. You cut out the picture, by the way. Don't cut the second sheet. Okay, just cut the picture. Extra. Okay, never mind. Extra. Cut the pictures out, okay? You have the meat, vegetables, and drink. cut this picture out. Okay. No, just cut one by one like that. You know, just cut each one. Just cut out each picture like that. Cut it out one by one. This picture only. Cut out the picture. Just cut.
Did you cut all or just...
No, the cut. No, I mean, the cut each one of them. Just a small little. Cut all of them. Cut all of them out one by one. 1, 2, 3, 4. Used to have 8 small little pictures. Yeah, individual, yeah. Altogether, you have 8 small pictures. Just cut it out. What's that?
What do we do with the blank square?
No need. Blank square, no need. No, just a picture. Just a picture only. Okay, don't worry about the blind one. Just. Okay, have you all cut out the pictures? Okay, yeah. You don't be perfect. Just cut out the picture now. Okay, you wouldn't make it so pretty. Okay, now those of you have finished. Assuming that you are in the canteen and you want to choose, the only thing that you can only choose 1 meat, 1 vegetable, and 1 drink. The question is, how many ways can you choose your meal? Can you list it out? Okay, now you write out for me how you choose it. Can you write on the next page there how you arrange it? At the back, you see there's a table. Now you can use the acronym here, like fried chicken, use FC, okay, kangkong is KK, so you can use all this abbreviation there. Just write the back, arrange it for your meats, your vegetable, and your drink. Just write it down, okay? You arrange it. See how many times can you arrange it? And I want to see how you arrange it. That's a question I want to know. That's important. How you arrange it. How you write down this one. How many meals can you have? And you write, see, I want to see how you write it down. Okay? I'm not interested in the answer. I want to know how you write it down. That is what I'm looking at. How many ways can you write down? Okay?
Wait, do you want us to write it like this?
Yeah, you can just write acronym there, and then these are the, okay, one column is for the meat, one column is for the vegetable, the last column is for the drink, okay? Just, yeah, you just write it down. No marker pen. Marker pen. Yes. How many times?
18.
Okay. How do you write down? Okay. Well done. Okay. You do very well. Yeah. Okay. I want to see how you list it down. I know, but I want to see how they list it down. That's the key thing.
As long as different, right? One different.
I don't see how they do listing, whether it's listed systematically or randomly. That's the question I want to ask. I'm not worried about the answer. Thank you. Am I right?
How you gonna arrange it?
Because at the end of the day, I'm talking about this one here.
Oh.
That is what I'm looking at. I don't know how you write. Just write down. Just write out using the acronym there, like, you know.
Can I have like an example how you write the name?
Then how come my video is? What happened to my video? The video is black out here. Hello. What's happened to the video? Where the video black out? What happened? Oh, the switcher. Oh. Okay, how you write? Okay, you just use acronym. For example, you can just FC. For example, you write the first meat, right? The first column is like FC, for example, and then you choose your vegetables. Let's say you choose the kangkong, you put KK. You follow me? So that's how you write it down. And then lemon tea, you just choose lemon tea, you put LT. So that's one choice. Am I right? You keep writing it down. Okay. Yeah. How many ways you can write it down? I'm going to see how you write it down, how you list it down, how you list it down. Okay. That's how you list it down. How you list it down? Okay. Okay. You choose the what first? What's that? Okay. So you choose the kangkong, you choose this one. Good. Okay. Right. Do it slowly. Yeah, see how you go. How do you list it down? Let me see yours. Okay, well done. Can you do listing in a different way besides in the tabular form? Any good? Any want to suggest any other way of drawing it? Any way
By any other way of drawing it.
of drawing?
Oh.
Can you draw in any other way?
Draw in any other way?
No, I mean what you have is the tabular form, right? It's a table, right? You do a listing, fair enough. But I'm asking you, is there any other way of tree diagram? Have you used tree diagram? Okay, there's another way. Very well. Well done. Okay, you can use a tree diagram to draw it. Correct. See, so there are many ways to list out, your solutions here. How many ways that you have, by the way? 18 ways now. How do you get 18? 3 times? 3 times 3 times?
No, 3 times 2 times 3.
Oh, 3 times 2 times 3. Okay. What do you call that?
Basic counting principle.
Basic counting principle. Very well said. Okay. And you need that, by the way, in mathematics, though. All right. So that's important. Bear that in mind. And this other thing here is very commonly used in mathematics. Okay. So this is a very simple example to see how you cut a meal. All right. Fine. Now you list it. I'm sure many of you will list. Let's say I want the fried chicken first, right? So I see most of you will be doing this one, correct? You will list out in this way. Then what do you have? You have a spinach, am I right? SN. So you list out this one first. Then you will list out the other one later on, correct? If you use a tree diagram, what happened? A lot easier to see. You follow me? Yes. So, oh, by the way, have they learned probability in grade 8? Not yet. You need a tree diagram, I think, this year in grade 9. Okay, so that's very useful in this kind of a drawing there. All right, this is a very simple one, just so to get you going first. Something's wrong, trees frozen. Okay, let's look at another one. It's called the Pascal honeycomb. Okay. Hey. Now, all of you know what's a honeycomb? What's honeycomb? Okay, good. Okay, so now we're going to look at the honeycomb. Now, this honeycomb, am I right? What's the shape of the honeycomb?
Hexagon.
Hexagon, well said. Why hexagon? Why the bee want to make the honeycomb in the shape of a hexagon? Why not a triangle?
There are 2 reasons I can think of. One is because it interlocks well with itself.
Okay, it interlocks well itself. Very well said. The interlock with itself. Okay, that means you can link together very well, right? What do you call that in mathematics? We call that what? If all the shape fits very nicely, no gap in between, what do you call that? It's called start with T.
Tessellation.
Tessellation, well said. Okay, tessellation, that's the word. You learned that in the primary school, am I right? To do tessellation. Yes, tessellation. But why must you? But you can also tessellate with triangle, am I right?
Yes.
You can also tessellate with square.
Yes.
So is this one. Okay, no, but not this one. Can you tessellate with this one? You cannot. But why B must choose this one and not the others? So there must be a reason why, by the way. Okay? Yes?
It needs the least amount of wax to make.
Okay, good. Well said. I think you're quite well read, I suppose. Good.
Do you know bees are mathematicians? Bees build honeycombs where they live, breed, and store honey. The honeycombs are made using wax. This wax is not so easy to produce. To make 1 ounce of wax, bees need to consume 8 ounces of honey. So they must make a structure using a minimum amount of wax while being able to store the maximum possible honey in it. What shape would be the best for this? In other words, what shape will have the maximum area if the perimeter of all the shapes is kept constant? Let's start with the triangle. Each side is 10 centimeters, so a perimeter of 30 centimeters. Let's fill it with these beads. That's 21 beads. Now, here's a square with each side of 7.5 centimeters. So, the same perimeter, 30 centimeters again. If we take all these beads and put them here, there's some space left. So, the area of this square is more than the triangle. We can fill it with some more beads. A pentagon with the same perimeter. Some more beads can go here. Hexagon. Even more. The area keeps increasing with the number of sides. So the largest area must be of the shape with infinite sides, and that is a circle. So why do bees use circles? Well, because it leaves a lot of gaps, wasting space and making the structure less sturdy. What about polygons? Triangles don't leave any gaps. Same with squares. Pentagons, 3 of them joined together leave a gap, while bringing in a 4th one makes them overlap. So pentagons don't work. Hexagons, they can be arranged like this without any gaps. 3 hexagons meeting at any point. What about heptagons? 2 leave a gap and 3 of them overlap. Same with octagons and every other polygon after that. So only triangles, squares and hexagons to choose from. And with the same amount of wax, which one will have the maximum area? Hexagons. And that's why a hexagonal structure is what the bees use to store their honey. So bees don't just buzz around, they do the maths too.
Bees can do mathematics, huh? Okay? Used to do better than the bees. Fair enough? Yes. Okay, let's go on then with a honeycomb. Okay, we have this what we call the Pascal honeycomb. Now, by the way, that guy was Pascal, Blaise Pascal. He was a French mathematician. Okay. Now, there's some interesting story about him, but I don't have time to talk about the story. I have time, I'll tell you the story about Blaise Pascal. Okay, so he has created this honeycomb named after him. Of course, it looks like what? A triangle, am I right? It's a triangular shape. So therefore, sometimes we call it as a Pascal triangle. So we call it Pascal triangle, Pascal honeycomb, it's the same thing. Now, you say, why he's interested in this honeycomb? Well, that's what he had done. He started filling up with these little cells, not honey, this time around with numbers. So he put down a 1 on top. And he put another 1 on the second row here. Now, when it comes to the third row, he put a 1 here, but these 2, what happened to 2? Do you see that these 2 is the sum of these 2 on top? Am I right? 1 plus 1 is 2. So this is a 1. Now, if you go along that way, what do you think of this one? It's a 1. Am I right? What happened? What's this number here? 3.
3. 1.
Well said. You learn very well, you see. You can do it very well. Now, you're going to complete. Now, I have to give you the sheet here. Okay, you can complete it all together. This one. You complete the honeycomb here. Take it, pass around. You complete the honeycomb now, okay? Pass around, complete the honeycomb. If not enough, let me know. Raise your hand. You have me to distribute? Okay. The honeycomb is here. One more. Okay, here, one more, yes. Okay, bye. Everybody got one? Okay, one more. Okay, just a minute. Don't worry, you will get one. Here's one more here. Now you take the first page there, you fill up the first Pascal honeycomb, okay? Complete the whole thing. What numbers here? Huh? No, sure. Go ahead. Okay, don't worry. Give me one. Give me one set. Okay. Anybody has one? Okay, now you can fill out the first honeycomb here with the numbers. Now, since you can tell me, the next one is the 1, 3, 3, 1, right? Keep doing down until you finish the last row. Oh, you're very fast, huh? You write very fast. Are you sure you're correct? Okay. All right. Okay, just stop there. Yeah, once you finish it, just stop there. I'll do something else. Save for something else. Okay. Yes. So how fast is the addition, by the way? Okay. All done? Addition. Now, those who have finished, can you check and see whether it looks like this, your answer? Make sure every cell is correct, all the numbers are correct. You get it? You make sure that they're correct. Now you try, okay? The simple addition. Okay, everybody has got it. Correct answers? Okay, now let's see. Now, okay, so what? What's so special about this honeycomb here? Well, okay, let's look at what's happened to this honeycomb here. Let's start naming it to be row 0 to row 7. Here's altogether 7, okay? 0 to 7, 8 rows altogether. Let's put it this way. Now, do you notice that if you look at each row, 11 to the power 0 is what? 1. Okay, so that's a 1. So 11 to the power 0 is 1. 11 to the power 1, of course, is 11. Am I right? It's now. 11 squared is what? 1 to 1. Well said. 11 cubed. 1, 3, 3, 1. Hey, the honeycomb give me all the powers of what? 11. Is it true for every row? You check. Now, you can use a calculator. The calculator here, you can check. Is it true for every row? Yes or no? You try every row and see whether you get the same as what is in the Pascal honeycomb here. No. No, which one? 11 to the power 6. Anybody else? 11 to the power 5. Hey, honeycomb fails. So it's not correct. So Pascal must have made a mistake. Huh? He must be a little bit sleepy and then he just write down, all right? You think very carefully. Who can tell me what is the answer for 11 to the power 5? 1, 6, 1, 0, what? 5, 1. And you look at this row 5 here. You get a 1, but not a 6, but a 5. Am I right? And the last 2 is correct. So what happened? But don't forget, you know, these are the what? 10. This is not up to here. Everyone is a single digits. But up to this row, in row 5 here, in the middle 2, you got what? 2-digit number. 2-digit number. You learn something in your primary school. We call that, I think you learned already in grade 2. You call that what? Start with P. Place value. Ayo. Hey, do you remember place value? Ever since you are in grade 2, 3, I think 3, 4, the place value, right? Yeah, place value.
You know in Mandarin.
Oh,
I like Mandarin.
you know in Mandarin, good. How do you call it in Mandarin?
I forgot.
You forgot. You forgot. Interesting. Okay. Now, okay, listen. Actually, this row come out also be the same as 161051. How that happened? You look at it. You take the 15 is 15. You take these 3 to be the what? This is the 15 what? Actually, it's a 15 with 4 zeros. You take 15, I see 15. I take 15, right? 15 with 4 zeros. $15 with 4 zeros. The 10 here is 10 what? With 3 zeros. With 3 zeros. It must be 3 0 for the next one. 10. Look at this one. Another 10, right? 10 with what? 2 zeros. 2 zeros. 10 with 2 zeros. 2 zeros. And the last one is what? 51. And if I sum it up, what do I have? 161051. Wow. Oh, Pascal has not fallen asleep. His mind is still awake. Am I right? Yes. So therefore, now you go and try by yourself to see what is the answer for 11 to the power 6. Now you try it. First of all, get the calculator and you do it. And see whether or not it will sum up using the Pascal honeycomb here to get to the answer. You got it? Yes. And you can try for the last row if you want to. Row 7, it's the same. Yes. What you do is that, that's how you see, I take the 15, 1, 5, right? I will fill in this last one to be 4 zeros. You follow me? 4 zeros. So it becomes 15, 0, 0. Now come to this one here in the right. This one followed by 3 zeros, right? So it's about 10, 10 hundreds, 10 hundreds. So it's 10 hundreds. 10 hundreds place value, correct? Okay, you see that? Now you can try your row 6 and row 7. See whether it's the same as what you have. All correct? You found it? Yes, okay, good. Huh? That's how you will. Pascal give us lots of interesting things about numbers. Wow, huh? Interesting, huh? Okay, now wait, that's not the end of the show yet. Pascal also discovered something else. He discovered that not only powers of 11 will meet this honeycomb here, he also found that powers of 2 also meet this one here. Hey, that's interesting though. Now, look at it. 2 to the power 0 is 1. Fair enough? 2 to the power 1 is what? 2. 2 to the power 2 squared is what? 4. Look at it, 4 now. 1 plus 2 plus 3. Oh, what? 1, sorry. It's what? 4. Am I right? So just add up the rows here. You look at the next one. 2 cubed is what? 1 plus 3 plus 3 plus 1 is what? 8. Hey, he's right again. Oh. So this is a little honeycomb, huh? There's lots of interesting numbers there. You got the powers of 11. You got what? Powers of 2. Anything else that you can find from Pascal? Yes?
If you go down the diagonal of 1, 3, 6,
yes, I will come to the diagonal one. I discovered the diagonal, okay? I have a little Pascal here. He discovered it. You are right. Now, I give you a bigger one. Do you have a bigger one here then? Look at the bigger one. Now, you are right. If you look at it, do you see that this whole row of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down, right? What number do you call this one here? What kind of number? Huh? Not triangle numbers, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. What kind of number is that? We call that what? What? No name. Nameless numbers. We call it what? Natural numbers. Am I right? Very natural numbers. All right, so this is a natural number that you see. Right? These are natural numbers. Got it? Now if you see the second one here, what do you see? These are what? Triangular numbers. Do you see? What's the triangular numbers? Because you can what? Make triangles like this. Right? This is a triangle. Do you see that? You count the number of dots in this triangular shapes here. Is it 1, 3, 6, 10, 15? Look at it. 1, 3, 6, 10, what? 15. And you go all the way and you count whether the next one is like that. So they can go all the way down. And these are the triangular numbers. The Pascal honeycomb also tell you something about the what? Triangular numbers. Have you learned number sequence? Yes. In number sequence in grade 8? Good. Now, this is a number sequence, right? So they're triangular numbers, okay? Another number that you can discover here is like this. Watch out. I just draw a line here. Okay, I cut through all this hexagon here, okay? There's a 1, right? So I write a 1. Now, see, I write a 1. And I draw another 1 here. You see that? How? It's a 1 still, all right? It's a 1. I keep drawing it. What do I get? It cut to what? 1 and 1. Am I right? What's the sum of 1 and 1? 2. I draw another 1. What do I cut here? I got a 2 and what? 1. So it's 3. I do another 1. What's the sum of this number here? No. 1 plus 3 plus 1 is what? 5. And do another 1. 8. Hey, what number is this? Fibonacci numbers. You can have the Fibonacci numbers here, all right? So you can see that, you know, it's called a Fibonacci number. Fibonacci number. Fibonacci. Okay, Fibonacci was an Italian mathematician. Okay, this number, by the way, there's a story about it also. It came out in a math competition during his time for the students. And he came up with these Fibonacci numbers and turned out to be quite interesting numbers. Okay, I have no time to go into this one here. This is we call that is a number of natures. With nature, lots of Fibonacci numbers as such. All right, so that's what he has come up with. Now, can you please take your worksheet, page 2 here? Can you try to complete, first of all, the triangular numbers? And also tell me, sorry, okay, what is the 10th triangular number? Change the word to 20th to 10th. There's a typo error on page 2. Okay, complete the triangular number first, and then you try to complete the what? Complete the Fibonacci numbers below. Come on, you finish up. No, fill in the blank. So the triangular number, who can tell you what's the 10th? What's the 10th triangular number? Huh? 55, am I right? How do you get 55? Can you get it from the Pascal honeycomb here? How to get 55? Basically, you take what? 10 plus 45 is this cell here, right? It's 55. That's how you get it. You can see that 9 plus 36 is what? 45. Am I right? 8 plus 28 is 36. So you can look at it and you can literally fill in as many as you want. That's the beauty of the Pascal honeycomb here. All right? Now, okay. Now, I'm sure you know how to do expansion. Am I right? You have done that? Yeah, okay. Can you do it your way first, what you learned in the classroom? Can you give me the first two? Doing your way. The class. Write down, what's the x plus y squared is equals to, expand it. Expand it for me. Then do the same thing for x plus y cubed. Expand it. You expand it and see what happens. Okay, hello, very quickly. You get these two, x squared, x plus y squared, x plus y cubed. Can you help me to complete it on the board there? No, you can't complete it. The first one, x plus y squared. Complete my equation there. Okay. Go ahead, finish it, expand it. Expand it, I want to see the expansion of x plus y squared.
I know. I help you.
You know how to multiply out? Okay, never mind. All right, it's okay. Come on, it's okay, never mind. Okay, expand it for me, thank you. You expand it.
Yes. On the heart, my brother.
Okay, well done. Okay, good. Thank you. Now, who want to do the x cube? X plus y cube. Okay, you can? Okay, now do for me. You can borrow this one here, am I right? You can just use that one there. That's easy.
I feel like many people are going to be confused if I just do it like this.
No. You just expand it and simplify. Expand and simplify.
Pull out your pens.
Okay, well done. Okay, well, okay, good. That's how you do expansion, am I right? Now, I want you to make some observation. In mathematics, many things you learn by what? Recognize the pattern of it. You look at the first one, x plus y squared. You get what? X squared plus xy plus y squared. So you see that at the end, it's always it's a square of the x and a square of y. Am I right? Now, you look at what's the power here? Power 1. X is power 1. Am I right? What is power 1? The sum of two powers is what? 2. So in other words, the power of all these variables add up to be what? 2. Always 2. Watch out. Now, let's look at this one here. You start with x cubed, power is 3. Am I right? You end with a y cubed, also power 3. Now, in between, you look at it. X squared, power is 2. Y, the power is what? 1. The sum of the two powers? 3. So they always add up to be 3. The power. X squared y. The power, actually, this is what? X squared y to the power 1. Am I right? These two add together to be 3. Am I right now? Look at this one here. 3xy squared. X power is 1. Y power is what? 2. Sum 3. So in other words, the power add up is always what? 3. Okay. Do you see that, all of you? Okay, good. Now, another thing. You look at the powers of x and the powers of y. Do you see that the powers of x is getting smaller and smaller? Until finally what? No more x, right? Power 0. You see that? Power 3. X, huh? Power 3. Power what? 2. Power 1. Power 0. Look at the y. Any y here? No. So power 0. Am I right? Power 0 here? Power 1. Power 2. Power 3. So now you see the two variables. One, the powers is what? Decreasing. The other one is what? Increasing. Hey, that's interesting. So that is the beauty of all this aspect. You can see something here, right? Now, the hard thing, of course, is say I must work out all this. What do you call all these numbers here? There's a name for it in algebra. We call it what? Coefficient. Very well said. Coefficient. Okay? Coefficient. Yes. Okay. So you have to, when you do expansion, you must write all the coefficients. Am I right? Now you tell me what's the coefficient? It's a 1, right? 1, 2, 1. Am I right? This one is what? 1, 3, 3, 1. It sounds familiar though. Sounds like what? Oh, 1, 3, 3, 1. Hey, I saw 1, 3, 1. Am I right? You see it? Yes, I saw it. 1, 3, 3, 1. Oh, dear Pascal. I love you. You give me all the coefficients there. Am I right? Yes. You see that? He gives you all the say 1, 2, 1. 1, 3, 3, 1. Make life a lot easier for you to do expansion. Am I right to say that? Yeah, you must thank Pascal, okay? Yeah, so he will do that. And remember, the powers, one of them is what? Keep on decreasing. Decrease by 1. The other one, increasing by 1, right? From 0. Now, okay, since you can see this pattern here, can you now help me to do the second one? Use the Pascal triangle on the worksheet here to expand and simplify the following algebraic expression. Now you do it using the Pascal triangle or the Pascal honeycomb. See whether life's a lot easier if you use the Pascal honeycomb here to do the expansion. Okay? Yeah. Yeah, you have it there, you can just do it there. Huh? Yeah, sure. Yeah. You do it. Okay, do it. You meant to do it? This one here. Okay, you can use the Pascal triangle. Look at the Pascal triangle and then expand it now. Use the Pascal triangle to expand. That's a lot easier. Okay, yeah. And remember your power, one is what? Increasing, what's decreasing?
Like this.
Yeah, okay. 1, 4, 6. Is it? 1, 4, 6, 4, 1. Am I right? Hey. This one's what? 1, 4, 6, not 4. 1, 4, 6, 4, 1. Remember that? Okay, 1, 4, 6, 4, 1. That's for the x plus y to the power 4. And the 1 plus 5 to the power 5 is what? 1, 5, 10, 10, 5, 1. Am I right? No, it's the same. Just use it as it is. Use it as it is. No, just use it as it is. Okay. Use it as it is. You follow me? It's a lot easier now. Just use the Pascal, all these numbers here as what? As coefficients. That's simple. Am I right? Okay. That's okay. Now I'll show you. Okay. I will show you one here. Yeah. Okay. I'll show you one. Now let me say that which one you meant to do. Let's say I will do the 7. How about that? Okay. X plus y to the power 7. Let's say, okay. X plus y to the power 7. Now, what's the first one? Must x to the power 7. Am I right? Plus. Now, if you're not sure, you don't worry. You just write down all the coefficients first. Okay, I will have my x now. What's that? 1, 7, 21, 35, 35, 21, 7, 1. I can write out all those numbers there first. How about that? Okay, plus what? Plus 7, plus what? 21, plus what? 35. Am I right? Plus 35, plus 21, plus 7, plus 1. Fair enough? Now I'm going to fill all the things here. Am I right? Now watch. Power 7 is what? Smaller. It must be what?
6.
Yeah, 6. Y, 1. This one? This one increase, right? You see that? One goes up, one goes down. Oh, now you see that. Okay, good. Now you see that. Now this one go down, right? X to the power 4. This one go up, okay? You see, the sum must be always equal to 7. See that? 4 plus 3 is 7. 5 plus 2 is 7. Is it easy now? Okay. No. No, sorry. This is 3, 4. 4 is a 4. Huh? Right bigger. Too small. Okay. The back they can see. Okay. Right one more time. Okay. The big one is on. Okay. One more time. Is it big enough? Okay, I know that the first one is a 7, am I right? I fill in the blank for the rest of the coefficient first, okay? I will put a 7, I will put a 21, I will put a 35, am I right? Plus, I will put a 35, plus 35, plus 21, plus 7, plus 1, am I right? Now, see how I fill up there, okay? X, the power is what? Decreasing, fair enough. So I fill in what? X, so power 6, Y, Y1, very well. Okay, power 1, okay? So I, good. Come to the next one, Y, 2, okay?
X power 4.
Power 4,
Y power 3.
Y is the power of 3. Next one,
X power 3.
next power 3,
Y power 4.
Y the power of 4,
X power 2.
X to the power of 2.
Y power 5.
Yes, okay, next one,
X power 1.
6, am I right? This one, 1,
Y power
7. You see that? You see the pattern? And you use the Pascal triangle to write down all the coefficients. You see that? Then X and Y, one of them keep going up, the other one keep going down. Okay, you see that? That's how you write it down. So Pascal help you to write very quickly. If you would expand it many times, it's a much longer time. Fair enough? Is it nice to have Pascal? Okay. Yeah, Pascal help you a lot of things here. Any questions so far? I'm sure you can complete the rest already quite easily. Can you do it now? Can you all do it now? Okay, good. It's quite easy now, right? With the Pascal's help. Okay. Let me tell you one thing about when you learn, listen, when you learn mathematics, what is mathematics? Basically, mathematics is the study of what? Patterns. The loss of patterns in mathematics, to be honest with you. So I think that when you learn mathematics, learn to what? Identify patterns, how it looks like. Even like the expansion like this, there's a pattern there, am I right? So first of all, I can get all the coefficient there from what? The Pascal honeycomb here. Secondly, I can see that the powers of X and Y is different. One of them is what? Decreasing, one of them is increasing. So these are patterns that you learn to recognize. You follow me? Okay. I think maybe we have a short break now. Okay, take a short break. And then we'll come back in about 10 minutes time. Shall we?